Hello everyone, welcome to Dennis Simplifies. Today we are going to evaluate sin s squared in C++, but as usual, we are first going to write the algorithm and then use the algorithm to model our code in C++. So let's simplify. Write a computer solution for evaluating the value of sin s squared according to the formula. Your computer solution should also return the number of terms needed to evaluate sin s squared to 1 in a million, together with the value of sin s squared for a given x with appropriate captions. You must put in check so that your computer solution accepts x as input if and only if the absolute value of x is less than pi over 2. To the algorithm. Since we are dealing with pi over 2 radians, we ask the user to input x in radians. So we say input x, which will be in radians. Since the value of pi is an ending, we are going to assign a value to it. So we say pi equals 3.14159. We are asked to evaluate sin s squared. So we will create an empty variable called sin s squared, where the value of sin s squared will be stored. So we say sin s squared equals 0. I equals 1. As we go along, I'll explain why we are saying I equals 1. From the question, we must put in check so that your computer solution accepts x as input if and only if the absolute value of x is less than pi on 2 radians. Meaning, in case the user inputs an x value that is greater than or equal to pi on 2 radians, we should give the user the opportunity to enter another x value, and this time the value of x must be less than pi on 2. So we say while the floating absolute value of x is greater than or equal to pi over 2, print the value of x must be less than pi on 2, input x, and while. So this loop will continue to run until the user inputs a value of x that is less than pi on 2. So to keep giving the user the opportunity to input x in radians that is less than pi on 2. Now let's go to the critical part. This formula we have here can be simplified to one general formula, which is sin s squared equals sigma from 1 to n of -1 to the power I plus 1 times 2 to the power 2 times I minus 1 times x to the power 2 times I, all on the factorial of 2 times I. You see, there is an I in here. That is why I initialize I to be 1. So now we are going to write sin s squared out of this expression. So we say sin s squared plus equals -1 to the power I plus 1 times 2 to the power 2 times I minus 1 times x to the power 2 times I, all on the factorial of 2 times I. You notice that the operation signs keep changing from negative to positive, in formula. This negative I to the power I plus 1 will take care of that. So anytime we solve for a term, we are going to store its value in sin s squared and then solve for the next consecutive terms and keep adding until infinity. So you see plus dot 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 till infinity. One thing you notice is that these terms actually run to infinity. What it means is that as they run to infinity, their values are going to be so infinitesimal, so small, so insignificant that there will be no need to keep adding their values to the previous values. Example, if I have 1 plus 0.000001, which is still 1 because the 0.000001 is too small. It has no significance. And according to the question, we should evaluate sin s squared to 1 in a million. That is, we should evaluate sin s squared to 10 to the power -6, which is 0.000001. So as the terms approach 0.00001, which is 1 in a million, we should not add the value of any term no more. So how do we do that? We keep a copy of sin s squared in previous value, which is empty, which is 0, and, and solve for sin s squared using this expression. Increase I by 1 for the next consecutive terms. Now, while you do these commands, be constantly checking if the difference between the previous values and the next consecutive terms, which is x sin s squared, is approaching 1 in a million. So we'll be constantly checking if the previous terms and the next consecutive terms, if their difference is approaching 1 in a million. When this becomes the case, you should stop the loop and print the value of sin s squared. Since we are using a do while loop, I, which started from 1, will be 1 more than the number of terms because we increase it by 1 before we check condition. So the number of terms will be I minus 1, and we print that as well. Now the factorial we have in here has not been defined, so we will create a different function that defines it. In our factorial function, we initialize fact to be 1. Then we say for I equals n to I greater than 1, step -1. Fact times equals I, return fact. The idea being used is that when you give a value n, which is stored in I, and I multiply that I by fact, we should decrease that I by 1 and multiply it by fact again, and then decrease it by 1 again and multiply it by fact. So I should keep decreasing and multiplying until I is greater than 1, because even if I multiply 1 by fact, I'll still get fact. So now let's take n to be 3. 3 times fact, which is 1, is 3. I, which is decreased by 1, becomes 2. 2 times fact, which is 3, gives me 6. We said I should be greater than 1. So we return fact. So 3 factorial is 6. Alright guys, we are through with the algorithm. Let's take a look at our code in C++. But before then, I will encourage you to pause the video, give it a like, and subscribe. Very well, to our code in C++. So I include CMath for the power library and declare my factorial function. In the int main function, I declared pi sin x, previous value, and x as a double, and I initialize pi and sin s squared to 3.14159 and then 0 respectively. Then I said int I equals 1, cout, enter x in radians, c in x. The user should enter the value of x. Then my while loop, which will check that the user's x value is less than pi over 2. Then do while loop, which will evaluate sin s squared to 1 in a million. Then cout, that is, I should print the value of sin s squared and then print the number of terms. Then from here, outside this function, I'm going to create a different function for factorial, which I have declared on top there. And then I'm going to define it. So here we have it. The int factorial, int n, and then int fact equals 1, and then my for loop, and then I'll return fact. So from here, I am going to input an x value, and then we will see how our code will run. So it says enter x. I entered 0.22, and on pressing enter, it says that sin 0.22 squared is 0.0476242, and the number of terms is 4, which is correct if you check on your calculator. So our code is running properly. Alright guys, that's it for this video. Don't forget to like and subscribe. See you in the next video. Till then, Apatia!